Okay, this is a video on polynomials, operations with polynomials, specifically adding, subtracting, multiplying, and dividing. So first of all, what is a polynomial? A polynomial is an expression for which the variables have integer exponents. So, for example, this is a polynomial. Specifically, it's a trinomial. This would be a polynomial. As soon as we take the number in the exponent and we make it maybe negative, it's not a polynomial. Or maybe it's a radical, it's not a polynomial. Or the x is in the fraction, it's not a polynomial. So, they're basically nice expressions with whole integer exponents. The coefficients can be negative. The coefficients can be negative or can be fractions. The degree of a polynomial is the highest power. So for example, if I had 5x to the fifth plus x squared minus 1, the degree of this polynomial would be 5. And the leading coefficient would also be 5. It's the number in front of the leading term. So the degree is the highest power. The leading coefficient is the leading term. Here. Okay, so let's just talk about adding and subtracting. This involves combining like terms. For example, if I had 3x squared minus 2x plus 1 minus 4x squared plus 2x. First thing is I'll distribute the negative to both terms. So I have 3x squared plus, minus 2x plus 1 minus 4x squared minus 2x. And then I look for the like terms. Negative 2x and negative 2x are alike. That becomes negative 4x. 1 doesn't have any like terms, and then I have 3 minus 4. So the degree of this polynomial is 2, and the leading coefficient of this polynomial is negative 1. We could step this up by maybe introducing a monomial on the outside. So in this case, we have to distribute twice. First we'll distribute here. So we have x squared y times 2x minus x squared y times y plus x squared y times 1. So this is this whole piece right here. We just distributed the x squared y to each term. Then we move to do the negative x squared times xy, and negative and a negative make a positive, so this becomes x squared times y. So that's this piece. Okay, so now we're going to simplify these terms, and then we'll look for like terms. So this becomes x to the third y. This becomes x squared y squared. This becomes x squared y minus x to the third y plus x squared y. So I don't have very many like terms here. This is 2x cubed y, and this is negative x cubed y. So that's going to become 1x cubed y. And then I have x squared y here and x squared y here. So that becomes 2x squared y. And then lastly is the x squared y squared term. So that's basically adding and subtracting. Then we get into multiplying. So the easiest form of multiplying is doing a binomial times a binomial, which would be something like 2x minus 1 and 3x plus 4. You have a couple methods that I went over in class. I'll show you the 3 methods here so you can practice. The first method that you can do is distributing. To distribute, we would distribute the 2x to each term, and then the 2x to the 4. Then distribute the negative 1. Then combine like terms after we clean it up. And you get 6x squared plus 5x minus 4. So there's the first method you could do. The second method you could do is FOIL, and it only works for binomial times binomial. FOIL stands for first, outer, inner, last. So we would have first is 6x squared, outer is 8x, inner is negative 3x, and last is negative 4. And I still end up with 6x squared plus 5x minus 4. The last method, the third method, is the box method. And this is where you make a box with all the terms and you multiply the corresponding parts. So for example, this would be 3x and 4. So I would do this times this, I get 6x squared. Here I get negative 3x, here I get 8x, and negative 1 times 4 is negative 4. Then you combine like terms. 6x squared, these are like 8 minus 3 is 5, and then minus 4. So either way, you get the same solution. You can do any method that you choose to FOIL. The next most complicated would probably be maybe if you had something like x minus 2 times 2x squared minus x plus 3. So FOIL is not going to work here. So you have two options. One is to distribute. So you can do the vertical method where we distribute the x. So let's distribute this x, 2x to the third minus x squared plus 3x. And then when we distribute the negative 2, we can line it up plus 2x minus 6 so that my terms line up in their like terms. So this would just be 2x to the third minus 5x squared plus 5x minus 6. If you want to write these on one line, you can when you distribute. You don't have to align them vertically. You could have distributed and then distributed the negative 2 and then looked across for like terms. Sometimes lining it up this way just allows you to see the like terms on top of each other. The box method would also work for this one. If you wanted to do it that way, you would have x at negative 2. And then on top you would have 2x squared minus x plus 3. So you'd have 2x to the third, negative 4x squared, 2x, negative 6, negative x squared, and 3x. Notice that the diagonals are like terms. So again, this gives you 2x to the third. This is negative 5x squared. These combined make 5x, and then I have minus 6. So box method or distributing works for that. The most complicated would be doing a trinomial times a trinomial. And that would be something like this. If you wanted to do the distributive method, then I would suggest aligning vertically. So first you'll take 2x squared to each term. So you'd have 2x to the third plus 2x to the fourth plus 4x to the third minus 6x squared. So that's taking the 2x squared to each term. Then take the negative x to each term. So my negative x times x squared, that's negative x to the third. I lined these up so they were alike. Then I do negative x times 2x, that's negative 2x squared. And then negative x times negative 3, that's positive 3x. And then I have to do it one more time. So now I'll do the 1 to each term. 1, 1, 1. 1 times x squared is x squared. Again, I just moved over so that these lined up. 1 times 2x is 2x. 1 times negative 3 is negative 3. Now I can add all these together. So I get 2x to the fourth plus 3x to the third minus 6 minus 2 is negative 8 plus 1 is negative 7 plus 5x minus 3. You can also do the box method for this if you choose to do so. A big grid of 9 boxes. 2x squared, negative x, positive 1. X squared, 2x, negative 3. And then go ahead and multiply your terms. 2x to the fourth, negative x to the third, x squared. 4x to the third, negative 2x squared, 2x. Negative 6x squared, 3x, and negative 3. And again, the like terms are in the diagonal. So 2x to the fourth is by itself. And then I have negative 4 minus 1 gives me 3. Negative 6 minus 2 plus 1 gives me 7. And 2 plus 3 is 5x and minus 3. This box method only works if the terms are in descending order, as far as the diagonals being the same terms, common terms, only if these are in descending order, to the second to the first, and just a number. I want to do one more problem just to show kind of the order of operations behind some of these things. So let's say I had a problem like this. What does this notation mean? Well, this notation means that I'm going to do x minus 2 and x minus 2. That's what this means when I square something. So we have a couple options here. When you multiply numbers, say we're doing 3 times 2 times 5. This is 6 times 5. This is 30. I can do 3 times 2 is 6. 6 times 5 is 30. Or I could do 2 times 5 is 10. 10 times 3 is 30. Or I could do, if I cover up the 2, I could do 3 times 5 is 15. And 15 times 2 is 30. So I can do any order I want. You do not need to distribute the 2x to both of these binomials because we don't do that when we multiply numbers. We don't do 3 times 2 and 3 times 5, so we're going to do the same thing here. You can do these first by foiling, and then distribute this. Or, if you want to, you can do these two first. And then you would FOIL this, so you would still get 2x to the third minus 8x plus 8. So it doesn't matter which one you do first. You want to pick two of them and then multiply by the last one. The same thing would apply if I had to cube something. You would have 3 of these. So you would FOIL these first, and then you would do your trinomial times a binomial, as the method I described up here with the box method.